Thank you for joining for this episode of the TechSpective podcast. My guest is Wilson Tang. So Wilson, if you want to give a little bit of background on yourself and your role.
Yeah, sure. Well, hello everyone. I'm Wilson. I'm currently a machine learning engineer in our threat hunting team at Adobe, and I'm focused on developing new ML applications, ML detections, to hunt for new cybersecurity attacks that we're not currently detecting at Adobe. Been here at Adobe for about 2.5 years. And before that, I was a fresh grad for my master's degree in computer science at the University of Washington. Did a good amount of software engineering in my background, pivoted over to ML, and haven't looked back since. And super enjoying my space in ML and security right now.
Awesome. Obviously, there's a lot going on with always a lot going on with AI ML. And there's been heightened attention to AI in the last 2 years with the ChatGPT and the generative AI stuff. But one of the things that I've talked about frequently is that as cool as that is, and we talk a lot about it in the specifically in security circles, but it's like it's not new. Like AI was already a buzzword in security before ChatGPT. So like one of the things that I know, I've seen stuff that where you've talked about like rules-based security log detections and such. So with what you're doing at Adobe, like what are some of the challenges that you faced in terms of transitioning from kind of traditional methods to a machine learning based approach for that?
Yeah, for sure. Definitely with some of the challenges at first, looking at role-based detections is just more of the limitations of how broad your detections can really go, and certain types of detections that might not just be possible, with simple queries. And that's when we started to want to go into the machine learning space, like when we started thinking more, can we do this more of the data science approach, data analytics, especially because the volume of logs is just becoming, increasingly larger and larger. And so answering that main question, like what has been that biggest challenge to even apply ML in security, is kind of like bridging the two worlds closely together, because yes, like AI has been a big buzzword in security, but I feel like not too many people have really dived into it that much. So there's a lot of security terminologies and methodologies that we already have for writing detections, like with detection engineering, even with threat hunting. But coming at it, also combining it with the more ML approaches, like coming in with that ML methodologies and the ML mindsets, that how do we actually get these two use cases to kind of come together and actually have a security use case that can be solved by ML? When does it not fit? When does it actually fit? That's where I have been seeing, when we first started trying to apply AI ML, that was the biggest challenge. But now we're starting to become a little more mature, not fully mature by any means, but starting to figure out where to put ML in places that we can.
Okay. Yeah, when you talk about the volume of logs, and I think that going back to kind of the original point, that's a lot of the reason of why ML is not new to security or tech in general, is that the sheer volume of information that needs to be analyzed and processed is far beyond what you can actually do with any sort of manual approach. And so you need machine learning to even have a chance at doing it. Based on all of that, can you walk through? Is there a specific case that you can talk about where machine learning has helped you improve detection accuracy or efficiency compared with traditional outcomes?
Yeah, for sure. I think one thing I can talk about specifically where ML has proven as a really big use case, and especially when we're talking about like a lot of data, I think like big data is like a almost feels like a legacy term now, but like big data
Yeah.
approach is one security project that's like commonly known around the industry, but how we're implementing here is with user and entity behavior analytics or UEBA, and implementing this using anomaly detection algorithms and models. And that's like the general big concept. And then one of the big use cases that we've been trying to that can be solved really well with machine learning, but not necessarily with like traditional rule-based logic is primarily around like suspicious logins. And so if a user logs in from a suspicious location or like suspicious IP, then like we kind of want to know this. But in order for us to even know if a user on our network has a suspicious login, we kind of need to know what the normal or the baseline
Yeah.
behavior is. And this idea of baselining is like something that you can't really do with just a query or maybe very difficult. And the baseline varies within different users too. It's not just like the baseline behavior of everyone, but baseline behavior of a specific user. So anomaly detection really gives us the ability to establish a baseline of each individual user, and then if anything falls under, the standard deviations of a certain user, like I usually log in from California, but for some reason I just logged in from I don't know, New York all of a sudden, then we might want to alert on that, or if it's not common, then that's where anomaly detection really comes into play here.
Yeah. Yeah. I mean, and that is, I mean, there've been, versions of that, and obviously, the concept of, behavioral analytics and those types of things has been around forever. And I've always felt like that should be easy. I'm sure it's complex on some level. I always feel like it should be easier to just say, well, yes, I know that Tony Bradley logs in from Houston Monday through Friday from 8 to 5 or whatever. And if all of a sudden you see that Tony Bradley is logging in from Sao Paulo at 3 a.m. on Saturday, there's probably something you should look into. I mean, and it's similar to the logic that credit card companies ostensibly use. I mean, they don't seem to do it very well or consistently either, though, because I mean, I travel relatively frequently, and don't get flagged. I almost never get flagged. So I don't know. Yeah, I don't know. Maybe they're just smarter than I'm giving them credit for. Maybe they're connecting dots on the back end that I don't know about, and they're like, well, yes, you didn't tell us you were going to New York, but we tapped into your phone. We have location tracking. We know where you are. It's fine. But in the presentation that you did, and I'll reference it when I publish this so that people can see the presentation for themselves. But you had mentioned using machine learning to detect command obfuscation. So talk to me about what makes that detection particularly challenging, and how does machine learning give you an advantage?
Yep, for sure. So command obfuscation, in case anyone in the audience doesn't know, as a method, it's a way to make a certain command line intentionally unreadable to the naked eye, but it would execute the same exact logic as like the normal command. And there are definitely operational use cases of this, where like you might want to admin might want to base64 encode their PowerShell in order to like have it in less characters. But attackers can obviously use this method to hide some of their malicious command lines and evade certain detections. And what makes this particular type of detection challenging from a static rule space is that there are like so many like infinite ways to obfuscate a command line in like any language in PowerShell and Bash, that like just doing some stack rules on maybe like special character counts or like percentages, like maybe like frequency counts of this certain character, or white spaces as well. It becomes you're doing a lot of like manual tuning to get this number or threshold just right. And it becomes sort of inflexible to all types of obfuscation as well. And you'll kind of constantly need to update this logic if you want to, adapt to more types of obfuscation. And this is one of the use cases that I dived into in my presentation because this felt like one of the more quote unquote obvious places where you would apply ML to. This ML approach would be a little more generalized because instead of like having to tune these specific thresholds, we could just give the ML model examples. So some examples of regular commands, what do they look like? And examples of obfuscated commands, and what do they look like? And label them, obfuscated, obfuscated, and then throw it at the model, and then the model over time will learn what is obfuscated, what is not. And then, if you need to update your model, you can just throw more label samples at it, and then it'll start to learn from these new approaches as well. Yes, you do still need to worry some of the features that you're throwing at it. Like maybe you do want to tell the model, oh, look at the character counts for this command line or the frequencies. But it becomes but you don't have to like mark the threshold. Like I don't need to say like, oh, if there's 5 question marks in like the command, then mark it as obfuscated. You can just tell them how many question marks there are, and then the model will gradually learn about what number of question marks does it become obfuscated or not. And that way it becomes a much more flexible approach and more generalized approach to classify obfuscation.
Okay. Well, and so I think it's a good segue into my next question, because so we already mentioned we did the obligatory mentioning of ChatGPT, which has to be in every podcast. I think I've been contractually obligated. But the concept of large language models has obviously exploded. Like they're everywhere. Everything. There's a all the primary media attention, I think, goes to ChatGPT, a little bit less to Llama and Bard and whatever else, but I mean, ChatGPT is kind of the poster child of LLM's general purpose. So obviously that's all the rage. So how what has been the impact on what you're doing and what Adobe does for security purposes with LLMs as opposed to kind of standard machine learning? So like how are LLMs impacting what you do?
Yep, for sure. Yeah, I think just before I talk about like how we're doing at Adobe, like personally, like this ride, I think like kind of commenting on what you've been saying throughout this podcast so far, like ChatGPT, poster child LLMs, to me personally has been I've been loving the excitement because it's been generating a lot of like excitement about ML in general. Like I feel like ChatGPT, the like main difference, like as we said, like ML and security has been here for like a long time. But I feel like ChatGPT had really like was the one to put like a sophisticated ML model in like an everyday person's hand. And I think before this, like the big wave of ML was like within like Tesla, like a Tesla using their computer vision models for self-driving cars. But like that was only accessible if you could buy their car, even though they, their marketing is like, we'll make it a little more lower cost. But ChatGPT, go to the website, I can interact with this AI. And yeah, it's been really cool to see that. And as we said before, like there has been like all this excitement with LLMs, and I love to like explore to see where we can put LLMs, but at the same time, like there's also this hype to kind of force LLMs where they don't belong. And I kind of want to like touch into that a little bit because of course, like there are pitfalls of doing that. And the takeaway of the story of like how we've been using LLMs at Adobe is that LLMs like ChatGPT, Llama, they're generative models. Hence, you hear this term Gen AI. And these models are meant to generate text based on whatever you give it. They're not really meant to classify data points. Like they're not meant to be like, hey, look at this log. Is it malicious or not? That's not like, well, that wasn't the intended, or not that's not the intended purpose. It's not like what these models are built for. It's built to write a sentence that would make sense to you, basically.
Right.
So yeah, as a result, we've been most successful applying LLMs to more like process improvement workflows rather than like leveraging this LLM to write a new detection as like this detection model. So like instead of like instead of our anomaly detection algorithm, we're going to use an LLM instead. That's not kind of what we drifted towards so far. Could be proven wrong in about a year, but so far these LLMs haven't been great at classification, more better on the generative side.
Okay. Yeah, I mean, I agree that it's kind of put things on the map. I have used ChatGPT, somewhat extensively. I've played with other tools. I think that there are many very good tools. I think especially with ChatGPT, the thing that a lot of people who maybe aren't in tech or aren't whatever, need to make sure they understand are the limitations of, I mean, I did an interview last summer or whatever, when there was something in the news where someone had used Gen AI to deep fake some artist and make a song. And in the interview, they were like asking me like, well, all right, so is this Skynet? Is this the end? And I said, well, it's just, it doesn't have access to anything you don't have access to. I'm like, it's just Googling, and to get the answer, and using some sense of logic to try to parse together like what the answer might be. It doesn't know anything. To your point about trying to like kind of force LLMs where they don't belong, I think we're definitely in that bubble. To me, we are right now with generative AI where we were in like 1999, 2000 with .coms, where it's like there's so much momentum behind it, and there's so much like hype that every company in existence is like, all right, well, I need to how do I use generative AI? Do I need to make an app? Do I need to make an interface? Like, so everyone's doing it, but they don't really know why. Or and if you remember, it might be before your time, but in the .com boom, like everybody bought a website. But then after they bought the website, a lot of companies were like, okay, but why? What are we supposed to do with this website? And then so you saw a lot of those websites kind of like faded away because companies were like, yeah, I don't really know how to take advantage of this, and so there's a little bit of a learning curve as the dust settles, and I think we saw it with social media too. Like initially it's like, all right, well, I've got to get on Facebook, I've got to get on LinkedIn, I've got to get on Twitter as a company or whatever, but then trying to figure out, okay, well, what do I do with this medium? Anyway, that's all along. But getting back to what you were describing, though, one of the main issues or challenges, whatever, there's lots of talk about hallucination. Like everything comes down to the integrity and clarity of the data that you're using. The large language model is trained on or whatever, and tuning the algorithm that you're using to access that data or to analyze that data. So I guess like how is that process done for you in terms of fine tuning the LLMs, so that they're kind of optimized for security log analysis and do what you need them to do?
Yeah, for sure. If we talk more about like fine-tuning LLMs and how we take advantage of open source LLMs, it's definitely like a necessity. Like in general, as a security team, we're not going to be the ones that are building these LLMs from scratch. because we don't really have the time to do that. It could take months to pre-train an LLM and literally cost millions, billions of dollars to build these LLMs from scratch. So of course we need to leverage what's already built out there, like Llama, ChatGPT, in order to leverage them. So that either comes down to usually like the two methods of like fine tuning or using a RAG model, retrieval augmentive. I forgot what the G stands for, but with RAG doesn't require the fine tuning. So yeah, so sorry, what was the original question on it?
Well, I was asking how you what's the process for fine tuning LLMs for security log analysis, and but I think you addressed that some with the RAG.
Yeah. Yeah.
But so machine learning LLMs, they provide you with these advanced detection capabilities, but they also come with computational costs. I mean, computational and energy efficiency costs. I mean, there's lots of talk now about the environmental impact of generative AI. So how do you balance the need for kind of accuracy of what you're trying to do with the limitations you have in terms of computational resources?
Yeah. Definitely don't want to train an LLM for the sake of fine-tuning LLM and just eat up GPU hours because of that. So I think what um, usually works here for us is that starting small, it doesn't have to be a big, huge ML model. You don't need to have the billions of parameters in Llama, ChatGPT in order to just have some classification or anomaly detection model working. So for us, a lot of the times, just sticking to smaller classification models may really be all you need or most what you need. So, where to the point where using more complex models, even diving into the deep learning space, what before LMs blew up, just using more CNNs, LSTMs, even those ones may only give you marginal improvements based on whatever use case we're doing in security. And yeah, I'm talking about this strictly within the security scope. Of course, if you're building a self-driving car, you'd want to use a computer vision model. But when we're looking at logs and maybe the fields are a little more simpler and you probably don't need too much computation power in order to already build an ML model. And yeah, so starting small and as a good practicing ML engineer, you should be comparing the performances of these different models and start with the static rules and then maybe build up with a simple ML model, see how the performance is, and then keep improving your model if you need better performance.
Okay, yeah, that makes sense. I mean, and I've talked to a couple companies that have said that they don't, they're not using ChatGPT per se, but they see the value in the concept of an LLM and a generative AI approach, but to your point, they're training it on a much smaller set of data, and to be a more focused LLM, a more focused instead of saying, "Hey, ChatGPT, I want you to train on the entire internet and be able to answer any question thrown at you." It's no, I have this database that's specifically about this one topic, and I only need this LLM to answer those questions. It doesn't need to know everything. It only needs to know this.
Yep, exactly to that point. Yep.
And also on the point of the energy consumption, it's my I have 7 kids, and some of my kids are actually sort of morally opposed to generative AI because of the energy consumption. And I have tried to tell them, I'm like, listen, I empathize, I agree with you, and that is a problem we need to solve, but that genie is out of the bottle. You're not going to get rid of generative AI, so you better start working on figuring out how to make it more energy efficient, because it's not going away. But it's very infuriating to them to see, if you go out on Facebook or whatever, it's everyone's just playing with it. Everyone's like, well, what if I tell it, make me a picture of a dog fishing off the back of a yacht? It's like, it's like, well, maybe don't waste all the energy in the world so you can make dumb pictures.
Yeah. Yeah, that's a really good point.
So, we've gone from, standard AI ML. Now we've spent 2 years, with all of the hype around LLMs and ChatGPT. You're actively working on, all of these things within Adobe. What's next in your mind? Like, what's the next big breakthrough? What's the next evolution in terms of using ML or LLMs for cybersecurity?
Yeah. Yeah, that's a big one. I think there's like a couple things I'm still excited on. I know like a lot of this podcast, we've been like talking about like the trade-offs of LLMs and maybe like fitting them to where they don't need. But I'm still excited to see how LLMs will progress. So like as I said before at Adobe, like we've mainly been using it as like process improvement tools, like more AI assistants. They're also what I'm excited about is like there are a lot of AI startups doing like SOC automation for using these LLMs to, help us write queries or, look at different log sources, maybe not making decisions, but gathering the intelligence quicker. And I think that is sort of the place that I'm still excited about what that LLMs can still give us, quicker investigation times in that way. And yeah, and then other part of ML other than LLMs, just talking about our UEBA project, I think there are UEBA products out there. I just don't think many of them are as well known. But I think because there's more of this hype in LLMs, I do hope that like there's just more attention to doing other types of ML in general and just growing the anomaly detection space as well. And even like looking past ML, I think, um, I think like this ML has been on the rise for so long, and here we're starting to feel some of the peak of it. I don't know if it's going to keep going up, but at some point maybe ML will die down. I think like one of the things I'm looking forward to is quantum computing. Quantum computing has also been on the rise for a while, but not realized yet to its full potential. And I do think that like at some point, once quantum computing is more established, that like it would really change the game of what we're doing in cybersecurity, especially going around like breaking cryptography and breaking keys.
Yeah, that'll be fun for some and not so fun for others.
Yeah.
What was I going to say? I was going to say that one of the things that I think we will see as well, and you already see it to some extent, but if you take Google as the example, so Google came on the scene. It wasn't the first search engine, contrary to what some might think. but they did fundamentally change kind of the approach and like how indexing is done, and so it was a little bit of a revolution. So Google changed the game, and we went through a lot of the same objections. Like you had businesses and schools telling people, well, you can't use Google, it's cheating. And eventually it becomes, well, you'd better use Google because otherwise, how are you going to get your job done? And I think we're in that place with generative AI and LLMs, and even now, I forget the exact number of years with Google, but I don't know, 20, 30 years. Even now, it's a verb. People say, well, did you Google it? But that's not the whole picture. Like, there's an art to Googling it. There's an art and a science to Googling it. So like what I get, my results when I Google are going to be different than my dad's result when he Googles, because he doesn't know how to form the query right. And I think that's a lot of the generative AI side is there are people who are using it, and you can use it. You don't have to. You don't have to become an expert in it to get value from it, but the value that you get from it is going to be dramatically different if you just get good at forming the queries better.
Yep. Yeah, for sure. Yeah, like to your point on like comparing like ChatGPT to Google, like like even the term like large language model. I mean this was popularized with ChatGPT, but I mean before this was like just language models. Like language models have been here for decades, and like for like the past few decades, like language models have been doing the same problem that ChatGPT has now, quote unquote, solved. Um, like uh Before this was like BERT, and then you can go even further back and like find more popular ones. But at the end of the day, like a comment I want to make on this point is that the how like early in the podcast we were talking about like, oh, is this Skynet? Really, like ChatGPT has been this equation, this loss function that's training on has been the same for like the past like whatever decades. Like you look at the current sentence, and then you try to predict the next word after that, and then it just does that in a huge cycle. And I think that's kind of like on your point of like how you're saying like, ChatGPT more like this version of Google, like not this first search engine, but definitely one that has been doing it most effective.
Right. I mean, yeah, I mean, I think the goal is to get there. When we get to was it, it's what's the term? It's generalized AI.
Yeah,
And
general intelligence,
yeah, no,
general,
they need a different name. It
yeah,
doesn't sound so close to Gen AI.
yeah,
But anyway, I mean, the goal is to come up with something that is able to actually have a unique thought, come to but that's not where we're at right now. But that's a good segue to what I was going to ask you next, which is, obviously you work with LLMs. You're passionate about the concept of LLMs. Um, there's a lot of misconceptions out there. So like what in your mind are some of the misconceptions you've encountered, or you know what advice would you have for someone to understand LLMs in the context of cybersecurity?
Hmm. Yeah, so I guess addressing the point with misconceptions, talked about a little bit so far, but definitely like LMs are more should be more in the generative use cases, not within the classification ones. Um, and to your point on this or like this general intelligence theory, my personal hot take on this probably disagree with like the OpenAI founder, but I don't think with the current like LLMs and how they're built that we'll be able to reach there because this loss function, this equation is a little too simplistic to reach that unique thought level. It's really literally just trying to predict the next word given the previous words. And I think, a more sophisticated algorithm needs to come about in order for LLMs to reach this general intelligence. So I definitely think that like a big misconception, maybe not necessarily the cybersecurity, is that like we're giving a little too much credit to LLMs. Sure, they are doing really great, especially like at least in my daily workflow, like helping me code faster has been really great, but definitely don't want to hold them to such a high bar that like I personally I don't feel like in a couple of years that like the LLM the way it's built now will actually have a unique thought. But maybe someone will develop something better than this, and I'm proven wrong here. And so in the context of cybersecurity, um, yeah, really looking at LLMs, like as I said, like more for process workflow improvements, looking at it as an AI assistant to help you with your daily task rather than maybe trying to make a decision for you.
Okay. Um, so kind of winding downish, but so for other security professionals who are and I'm sure there are plenty out there who are still using primarily relying on rules-based detections and kind of old-fashioned methods. What advice do you have for them if they want to start incorporating machine learning into their processes, like where should they start if they want to build what you've built?
Yeah, for sure. Yeah, like more on like thinking about the costs. It kind of goes along with the cost side of things. Definitely like just start small. If you haven't really done too much ML in the past, but you've done like writing queries on your sim tool or stuff like that. Just take a beginner course on ML and learn the foundational models. Like look at logistic regression, look at random forests. For anomaly detection, maybe look at isolation forest and try using these smaller or like shallow models in your detections first before you try like going into the deep learning space, like looking at neural networks, looking at deep learning, LLMs. That'll hopefully make your learning curve a little less steep and just easier to ease into like the models. And honestly, you'll probably be surprised how much value you can bring with just these smaller models. Because like if you are like already like a security analyst, security engineer writing detections, you're kind of already doing most of the work that like you need in ML. You're already like gathering the data you need, pre-processing it, picking the exact fields and attributes that you need and columns in order to classify a detection. And you're really at that point where you just need to, instead of like, as I said with like the command obfuscation example, like instead of defining certain thresholds, just throw those fields into the smaller ML model and see if the ML model can actually learn correctly based on your detection. And yeah, I think you'll find that you'll probably be surprised how much value that it could just work and it feel like magic, but not super like magic, but it will feel like magic.
Right. Yeah, I mean, that's fair. I mean, and that's, again, it's like, I don't want to, I try to like, find the balance between, I don't want to just kind of slam, like the concept and say, well, it's not really doing any of these things that you think it's doing. It's not magic. But over here saying, okay, but it does do a lot of things very well. I mean, I mean, like I said, like you said, you use it for, some coding, like the things that it does pretty good. And if as long as you kind of learn what those guardrails are, like what does it do well and what doesn't it do well, and you can use it to accelerate your productivity. I mean, who knows what it'll be in 5 years, but I mean, right now you can use it to accelerate your productivity as long as you focus on what it does well.
Yep, exactly.
So anyway, I want to thank you for taking the time. As I think it's a fun conversation. I mean, and I'm also very interested. It's like I'm not a machine learning developer, but I find all of it very, very fascinating in terms of like what is possible and kind of where we're at in that evolution. So very interesting.
Yeah, for sure. Thanks for having me, Tony. This was a great talk.
All right, take care. I appreciate you investing your time to listen to the podcast, but I also invite you to engage on social media. Please go like our Facebook page and follow at TechSpective on Twitter and Instagram. You can feel free to let me know what you like, let me know what you don't like, let me know if you love it, let me know if it sucks, and let me know what products you'd like to see reviewed or what questions you'd like to see answered in future posts.